Hi, we are team number 12, and my team is confirmed by Buganza Machado Alejandro, Domínguez Ramos Miguel Ángel, Henry Vegán Becaila, González Hernández Gerardo, Miranda González Griselda, Ojeda Garzón Gerardo, Sánchez Vázquez Daniel Alejandro, Santos Caustera Iker David, Santos Reyes Andrés, Vázquez Orduña Diego, and Rojas Morales Diego André. And we are going to explain the topic Newton and the motion of the planets, that consists in the gravity and the Newton's second law. And now, I will let my classmates Kyla and Diego Vázquez to give you a brief introduction to this topic.
Okay, we are going to talk about Isaac Newton. Isaac Newton has been one of the most important physical in the human history. He meant a lot of things, and even he abhorred a lot of physics and mathematics. But Newton had an easy childhood. He was son of a poor landowner. He died when he was a kid. When he was 3 years old, his mother get married with another man, living with his grandmother and stay along with her. Years later, he started to go to Cambridge, to the University of Cambridge, and study philosophy. But years later, he has a lot of interest in physics and maths. So when he finished the university, he discovered all the laws that he presented to the Council of Cambridge. And years later, the world starts knowing the name of Newton. And in the year of 1727, he died for a kindly colics and bladder problem.
Better known as the father of physics, Isaac Newton is known for his contributions to humanity as well as science itself. His contributions were the famous three laws and universal gravitation. Gravitational law consists of the fall of the bodies on the Earth with the correct value of gravity, in addition to the fact that the inertial and gravitational masses were of the same nature. He first came up with the idea or thought while he was on his way towards a meeting at the university he taught at. He saw an apple fall from a tree. Without any reasoning, in his brain flashed a thought that the fall of an apple and the movement of the planets in the orbit must obey the same universal law. This thought allowed him to process a new, more mechanical philosophy, and he created hypotheses from the comparison of planetary movements, thus developing a new theory.
Now, let's continue with Gerardo Ojeda and the scientific Alejandro Buganza, who are going to give you the objectives of this project.
Hi, my name is Gerardo Ojeda Garzón, and today I'm going to ask some questions to a scientific from the NASA, Alejandro Buganza. Hi.
Hi.
The first question is, why did you choose this topic for your experiment?
Well, in the NASA, we try to look always to the future, and we think that this topic of the projectile motion is very interesting for the society and will help to know more about physics and how it relates with the planet.
Thank you. Why are you using the first law for this experiment?
Well, let me correct you, because we are not using the first law, we are using the second law. The second law of Newton states that acceleration of an object is dependent upon two forces, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the force of acting upon the object and inversely upon the mass of the object.
Right, thank you. What is the general objective?
Well, our general objective is doing a research about the second Newton's law to be able to identify and explain the law. Also to know more about how the physics is related with our planet.
And the last question, what is the specific objective of your project?
Well, our specific objective is identifying and explaining the reason that the shape of the planetary orbits around the sun has an elliptical shape, and create our own sources to prove that theory is completely true.
Thank you so much for your participation.
With that said, we are going to explain the technical part of this. Well, now we will continue with Iker Santos.
The scientist Isaac Newton established three fundamental laws based on the studies of Galileo Galilei and Descartes. That are the three most important. The first one is the law of inertia, the second one is the fundamental law of dynamics, and the third one is the action and reaction. But here we're going to talk about the second law, which is fundamental law of dynamics. Newton's second law states that acceleration that a body experiences is proportional to the force that it receives. Newton's second law tells us that the relationship between causes, force, effects, and acceleration, it does not say anything about what other factors can influence these causes. As an example, can be the force of gravity depends on the mass and distance. The elastic force depends on the characteristic of a spring and its elongation.
Griselda is now going to explain how the second law and the gravity are related to the movement of the planets.
Hi, my name is Griselda Miranda, and I'm going to explain how does the second Newton law and the force of gravity are related to the movement that the planets has around the sun. Here, I can say that the Newton's second law are related to the gravity because it's an example. But now I'm going to explain how Newton's conclude that the gravity are on the space and how does it related to our planet. Newton's wrote and described that he questioned the existence of the gravity because one apple fell from the tree and hit his head. Later, he found the relationship of the movement that the moon has with the earth and the motion of fellow objects. Newton assumes the attraction between two big bodies. These bodies can be the earth and the moon, or the sun and the planets. And he concludes that this force not requires the contact like the others laws established, like the first law. Well, thank you, that's all.
Daniel Sanchez is going to explain the formulas needed for this second law.
Okay, so after that, I'm gonna explain the formula. The formula is quite complex, but I'm gonna explain it very well. Well, the formula explains that everything and all objects have a mass. And to calculate the mass to the object, we have to divide the force dividing by the acceleration of the object. And then we have to calculate the force of an object, and we need to multiply the mass of the object by the acceleration of that object. It will be a little confused, but to calculate the force is F equals M multiplied by A. M is also the mass and the A is only the acceleration. And to calculate the mass, it's F divided by A. F also known as the force and A also known as the acceleration. So that's everything for me. We're gonna go to the next scientific.
Now, let the experts perform the experiment and they will also explain to you some things about it.
If the sun and the earth attract each other, why didn't the earth fall towards the sun? Why hasn't it been enveloped by the sun? What is the thing that prevents it?
The answer is that the earth is falling. The magic is that the fall fails. Imagine that I grab the sun and the earth and release into space. What is going to happen? They will attract each other and eventually will have a crash. But what if in addition to releasing the earth, do I give a little bit touch to the right? Well, the earth will be attracted by the sun, but it will move to the right, on the way impacting elsewhere.
But wait, if I hit it hard enough to send the earth out of the sun, what will happen?
Well, the earth will fall towards the sun as before, only that the collision will fail. It would pass by its side, rising the opposite side of the sun, and then it come down in it again. This peculiar way of falling and never hitting isn't known to the whole world by the name of orbitating.
Thanks to the touch that we have given to the Earth, and that it has a certain lateral speed, it will continue moving in a straight line in that direction. However, the Sun exerts an attraction on the Earth. What it does is deviate the direction in which the Earth moves, which tilts its trajectory to the next step. The Sun attracts the Earth again and returns to deviating its route. The Earth wants to continue in a straight line, but the Sun forces to curve its path forever. The forces that curve the trajectory of an object are called centripetal forces. The solar system was formed from a large cloud of material that, Thanks to the gravitational attraction and enormous amounts of collisions, managed to form a rotating disk around the Sun. Over the time, the matter in the disk clumped together, forming planets and other bodies, each moving at the correct speed.
And that's pretty much it. Thank you for all watching and see you next time.